All right, so welcome back. Today we're going to be finishing up the notes 5.2. And today's topic is something called the reference angle relationships. So, to finish up this section, like I said, we're going to be talking about the reference angle. So, it says, let theta be an angle in standard position. So, we have to start with that. Theta is going to be our angle, and we're going to be drawing them like we did the day before for the previous video. And so it says the reference angle, so here's our definition, for angle theta is an acute angle that we're going to call theta prime. And back in our geometry days, we used to use prime a lot. The reason we're going to use the same theta, the same Greek letter, is because there's a direct link between theta prime and that theta, right? They're going to be connected somehow. And it says the reference angle for theta is the acute angle formed by the terminal side and, so here's the key, the x-axis. A reference angle needs to make contact with the x-axis only, never the y-axis. And then it says the relationship between theta and theta prime is shown below for non-quadrantal angles, theta, such that theta is between 90 and 360, or in radians between pi over 2 and 2 pi. Okay, so here's what they're trying to tell us. First of all, to be a reference angle, it says it needs to be an acute angle. All right, so first things first. We know that to be a reference angle, it has to be less than 90. So it has to be less than 90 degrees. And here's the other thing that people forget. I understand, and we already saw this in the last video, we have angles that can be negative. But when it comes to a reference angle, it's always positive. Think about taking the absolute value if you need to, but that's the key. It's always going to be a positive number. And yes, it has to be less than 90. So there's two things we got to watch out for when we're talking about a reference angle. Now, they also mentioned one more thing. And down here, we can write it down here at the bottom. They said it is found, or it is formed by the terminal side of theta and the x-axis. So here's the other big note that we need to mention. The reference angle, think of it this way. It's the shortest distance back to the x-axis. And yes, it is only the x-axis. We don't work with the y-axis on this. And if we're only going to the x-axis, then there's a couple numbers we're going to be working with over and over and over. So that's why when you look at these pictures, okay? So again, it's the shortest distance back to the x-axis, and we're only going to use the x-axis for this. We don't use anything else. So here they give us three examples, right, of how we find these reference angles. And there's some formulas down there. They gave it to us in radians. They gave it to us in degrees. So it can get a little interesting when it comes to that. But we're only going to work with degrees. We know radians is new for you. So here's what it looks like. What they're saying is this is my regular angle. Notice how it ends in quadrant number 2, right? So there's theta. Yes, it starts at 0. This would be 180. Notice I didn't write the 90 or the 270. Remember, this has nothing to do with the y-axis. So I'm not going to need those numbers. So if I want to find my reference angle, which is this one, this is the angle I'm looking for. I'm trying to find the shortest distance from the terminal side back to the x-axis. Now, if I'm right here, there's two ways I can get to the x-axis. I can go back this way, head towards 0 again, or I can go this way towards the 180. Well, that's what we're going to do. We want the shortest distance back. So I'm going to need to use this number 180 in order to find the reference angle. And so if you notice right here in degrees, as it says, like I said earlier, that we're going to work with, in order for me to find it, I'm going to subtract And I would start with the bigger number, 180, minus this theta, this angle that we just drew. That's the two things right here that we would subtract from each other. And that's what it says here. So if you notice, the note that we can write to ourselves is we subtract. So we're going to subtract to find the reference angle. And remember, the reference angle does go by a special name. They are calling it theta prime. So we're going to subtract in order to find it. And that's what they're doing here. Look at that. Notice how they went with the 180 first minus the angle we drew. Why? Because we have to guarantee a positive number. All right, let's try this again. See, when I look at this one, yeah, here's my theta. It's a positive angle again, which is fine. Has nothing to do with anything. There's my angle, so here's theta. But then they said, well, the reference angle is the shortest distance back to the x-axis. Well, again, if I'm standing right here on this line, the shortest way back to the x-axis is I either go all the way around this way or I just go like this. This is the shortest path back to the x-axis. That's why it says this is my reference angle right here. So we're kind of backtracking, but that's okay. Notice though, that means that if I backtrack, I need to use this 180. So you always have to know which two numbers you're going to use. I'm going to use the theta and the 180, but notice the theta is actually bigger, right? Theta is actually a bigger angle than this little mini theta, or bigger than the 180. So that's why I look at the order. When I subtract, the 180 goes in the back. The idea is subtract the big number minus the little number. So once you pick your two numbers, subtract them from each other. Last example, and I know there's no numbers on here, but I just need you to see these. Look at this huge angle they drew, right? It's in quadrant number 4 as they stated. So this is in quadrant number 4, big angle. So this is where theta ended up. This is the terminal side for that theta. But then notice, if I'm standing on this line, I have two options. To get back to the x-axis, I can go this way around to get all the way back to the x-axis over here, or I can just go this way. Look at that. This is a lot shorter. It's easier for me to go from here to there. So that is my reference angle. You always go back to the x-axis, never the y. Never the y-axis. Yes, I have to say that kind of loud because sometimes people forget. So the question is, well, am I using 0? No, 0 is way too far, right? 0 is where I started. This is where the 360 comes in. And again, another reason why it's important to know these numbers. So I would use the theta that I drew and the 360. And then what am I going to do? Well, I'm going to subtract. That's the rule here. It's all about subtraction. That's how I'm going to find that reference angle. And that's why when you look at your note, look at what it says. 360, take away the angle that you have. So it's an interesting little concept here, but look, let's give it a try. Okay. So for example, number 4, it says find or evaluate the reference angle for the examples below. All right, here it is. So the first one has a picture for us, just to guide us a little bit. Okay. All right. 300 degrees. So yes, they already drew theta for me. This right here is 300 degrees. So what I'm going to do in my picture, I'm going to put a 300. So yes, we're going to need to draw these. That's why you have a lot of space for it. So there's my picture. All right, now I drew it. Now I need to go the shortest distance back to the x-axis. The shortest distance back is to go like this. That's the shortest distance back. But if you notice at that point, I ended up finishing the full circle. So no, I'm not going to use the 0. I went around full circle to get to that 360. So those are my two numbers. My two numbers are 300 that I'm going to work with and 360. You have to know which numbers you're going to use. And look, I'm ready. For my reference angle, right, theta prime, Here's how I would find it. I'm going to go the bigger number first, so 360, and I'm going to subtract the 300. And just like that, my theta prime, my reference angle is just 60 degrees. And there, I'm done. I have officially found the reference angle just like they wanted. Now look at the checkpoints. Is it positive? Check. Is it less than 90? Check. Those are the two things you have to make sure that you're doing or that you get. Let's try this again. So look at 4B. It says we're going to draw an angle that measures negative 370 degrees. All right, here comes my little chart here. So there's the little chart. And we're going to go 0, negative angle, negative 90, negative 180, 270, 360. So if you notice, it's just after the 360. So here comes my angle in standard position. So there's the angle. 370 would be like right there. But I know that when I draw it, it has to go like this. Full circle, and then that little extra right there. Okay, well, here's what we said about a reference angle. And I know the angle's kind of small there, so let's really zoom in for this one. All right, my reference angle. I'm standing right here on the terminal, and it's the shortest distance back to the x-axis. Well, that means I got to go this way. All right, look, that tiny little angle right there. There's my theta prime. I know it's tough to see, but that means I have to use that negative 370 and the 360. Just remember what I mentioned earlier, though. When you're working with reference angles, we don't really work with negatives. It has to be a positive number. So even for this one right here that we're doing, all I have to do is go theta prime is equal to 370 is bigger. I'm going 370, take away the 360. And if you're wondering, hey, but I thought it was negative 370. Remember, we drew the angle. My reference angle needs to be positive. I'm just going, think absolute values. I'm going bigger number minus the smaller number. So that's why my theta prime, my reference angle, is simply just 10 degrees. And there's my reference angle. Okay? So yes, think of it as you're taking absolute values. Reference angles need to be positive anyways. Just go with the 370 and the 360. Okay? Look, let's try one of those again, another one of these negatives. And we'll do that. You try number 7 since it's kind of already drawn for you. Or, no, you know what? Let's do number 9. We're going to do number 9 together here to finish this page at least. Negative 570. All right, big angle, negative direction. Here we go. 0, negative 90, negative 180, negative 270, negative 360. We're not at 570 yet. I'm only at 360. All right, another 90. So just add 90 to 360. That's negative 450. Still not at 570. So I'm going to add another 90 to that. And now I'm at negative 540. Well, 570 is right after that. I'm not going to make it all the way over here because if I add another 90, that's negative, what is this, 630. So yeah, that's already too much. So I know that my angle is going to be starting here. I'm going to roll down this way. Look at that full circle. That's already 360. But I'm trying to get to 570. So I spiral it. And then I go right here. That's where I'm going to end it. So there's my angle. That's the negative 570 mark. Well, if I'm going to try to find a reference angle, we just said a reference angle goes, let me stand right here on my terminal, shortest distance back to the x-axis, never the y. So I'm not going to go all the way this way. That's too far. This is the shortest distance. That's theta prime. So what numbers am I going to use? 570. And because I went back to these, well, 180 wasn't it. Remember, if I was at 570, I got to go with the 540. And notice, I didn't even say negatives anymore. So theta prime, bigger number, 570, minus the smaller one, 540. Again, you don't worry about negatives because reference angles need to be positive. And just like that, we find our answer for our reference angle of 30. All right. So take a moment. You're going to do the you try 7, 8, and 10. Now there's only 3 left that you have to do there. And if you do finish those, please check your answers with the key. And at the same time, you can do the first half of the classwork for this as well.